What is electric potential? Let's consider 2 points A and B here. So let's say the voltage here at point A is VA, at point B is VB. Okay, then the potential difference. Remember, we always talk about potential differences. Okay, so potential difference between A and B, or let's say B and A, just to keep with the convention, between B and A, measured as VB minus VA. Okay, the sign is important, or the direction is important, right? So this is the potential at VB minus the potential A. So the potential difference between B and A, or VB minus VA, is the work required to move a unit charge from A to B. Okay, so that means if the potential difference VB minus VA, if that is positive, that means VB is at a higher B is at a higher potential than relative to A. That means you need to put in work to take its unit charge from A to B. Okay, so that's basically how a potential potential difference between 2 points is defined. Okay, so now A and B can be any 2 points in a circuit. So let's take a simple circuit. Say there's a voltage source, a resistor over there, another resistor here, maybe another resistor here. Okay, so R1, let's say R2 and R3, and this is V. Okay, so now at any given any 2 points, let's say this is A and this is B. Okay, so there is a potential difference between A and B, right? So let's say the potential difference between A and B, VA minus VB, is, again, let me not write the definition again. So it's basically the amount of work required to move a unit charge from B to A, right? So now usually it will be convenient for us to talk about potentials at different points on the circuit as opposed to potential differences, right? So in order to do that, we pick any point on the circuit and call that our reference point. So let's say I'm going to pick B and I'm going to call that as my reference point, and the way we indicate a reference point is using a ground. Okay, so that means all this means when I put a ground here, all that means is I'm saying VB is equal to 0. So what this means is then VA minus VB will be equal to VA. So taking B as a reference, now I can talk about potentials at different points on the circuit. But remember, I'm always talking about potential differences. But since VB is 0, and then the potential difference between any point and B is the potential at that point, right? So similarly now VA, now I can talk about VA as a potential at that point with reference to ground. Okay, now note that this also means that, let's see, so because let's say now I'm giving a voltage at V, let's say VA, right? And then VA is amount of work required for to move a unit charge from B to A, right? Now when I in that definition, note that it does not specify what path the charge needs to take, right? So let's say if I move a unit charge along R2, right, then I need VA amount of work to move it. On the other hand, let's say if I move the same unit charge through R3, I still need VA amount of work to move it. Let's say I move it using this path, I still need VA amount of work to move it. Okay, so that's right now that itself says, it tells a lot of things about what happens in a circuit, right? So when you have electric circuits and you, let's say, connect it to a battery, then the potentials inside the circuit arrange themselves in such a way that no matter what path you take, the potential differences between any 2 points is the same no matter what path you consider. That means no matter what path you use to move a unit charge, the amount of work you need to do will be the same in order to do so. Okay, so that is why, in fact, because the amount of work is independent of the path, that is why you can just talk about potentials at different points or potential difference between 2 points without referring to the specific path. Okay, so now let's talk about units, right? So I just said, the definition of potential difference is work done per charge, right? So that means the unit should be joules, which is work done, per charge is coulomb. Okay, so that will be the units for volts.